This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 7, Heat Pumps and Thermal Storage. This is a lean lesson because a heat pump isn't a new machine. It's the same vapor compression cycle from Week 3. Run for its heating output. We'll define the COP both ways. Show why the heating COP is exactly one above the cooling COP. Set the reversible ceiling on absolute temperature. Work one clean example, and treat thermal storage as a load-shifting concept. Concept. A heat pump is not a new device. It is the same vapor compression cycle as an air conditioner, run for its heating side. The air conditioner keeps the cooling. The heat pump keeps the heat rejected indoors, and a reversing valve chooses which coil is inside. So COP for a heat pump is heat delivered over work. For a refrigerator or AC, it's heat removed over work. We don't rederive the cycle. That's Week 3. And note the only handbook figure actually labeled heat pump is the heat-driven absorption diagram, a different machine. Here is the link. The cycle pulls heat QL from the cold outdoors and adds compressor work W. A first law balance sends both indoors as QH. So QH equals QL plus W. And dividing by W, the heating COP is exactly the cooling COP plus 1. That extra 1 is the compressor work, which also ends up as heat in the space. It's exact for one machine at one pair of temperatures. A real unit in heating versus cooling mode is at different conditions. Setup. No real cycle beats the reversible or Carnot limit, and it depends only on the two absolute temperatures. For a heat pump, the ceiling is TH over TH minus TL. For refrigeration, it's TL over the same difference. Those temperatures must be absolute, Rankine or Kelvin, so convert first, adding 460 to Fahrenheit. And the smaller the temperature lift, the higher the ceiling. Our givens: 70 inside, 20 outside, delivering 36,000 BTU per hour, 3 tons, on 3 kilowatts. 1 unit trap before we solve. Rating plates give capacity in BTU per hour, but input in watts, mixed units. The factor 3.412 converts watts to BTU per hour, so COP comes out dimensionless. Capacity over input watts times 3.412. EER is the same ratio left in mixed units, so EER is 3.412 times COP. Forget the factor, and your COP is about 3.5 times too big. Solve. Same givens. Step 1, go absolute. 530 and 480 Rankine, a lift of 50. Step 2, the heating ceiling is 530 over 50, 10.6. The cooling ceiling is 480 over 50, 9.6, and 9.6 plus 1 is 10.6. The plus 1 rule checking out. Step 3, the real machine. 3 kilowatts is 3,000 watts, so COP is 36,000 over 3,000 times 3.412, about 3.5. That's far below the ceiling, and that gap is real-world irreversibility. A COP above the Carnot ceiling is impossible. The other half of the lesson: thermal storage, ice or chilled water tanks. This is a load-shifting concept, not a formula. It isn't in the handbook. You charge at night, running the chiller off-peak when power is cheaper and the condenser is cooler, and store the cold as ice or chilled water. Then you discharge during the afternoon peak, coasting the chiller. The effect is to move electrical demand, kilowatts, off the peak. It barely changes total energy, the kilowatt hours. The win is demand charges and grid economics, plus a slightly better nighttime COP. 5. Traps. 1. The reversible ceiling needs absolute temperature, Rankine or Kelvin, never Fahrenheit. 2. Heating COP is exactly the cooling COP plus 1, not double, not equal. 3. The field COP divides by input watts times 3.412. Skip the factor, and it's 3.5 times too big. 4. The Carnot COP is only an upper bound. A real number above it is impossible. 5. Thermal storage shifts when you make cooling, not how much, and there's no formula for it in the handbook. Recap. A heat pump is the air conditioner run for heat. Heating COP is QH over W. Cooling is QL over W. And the heating value is exactly 1 higher. The reversible ceiling is TH over the temperature difference, on absolute temperature. The field COP divides input watts by times 3.412. And thermal storage is a load shift. It moves peak demand, not total energy. Same machine, 1+1, absolute temperature ceiling. Next, Lesson 8, Cooling and Heating Coils. The coil treated as equipment, a heat exchanger where air meets water, with the sensible and latent split and LMTD sizing. The psychrometric chart side, apparatus dew point and bypass factor, is back in week 1. Everything's at PEPrepengine.com, cheat sheet, work solutions, and a quiz attached here.
The full study guide with every equation and common exam trap is free at PEPrepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.